Let's continue our discussion of diodes, and in this video what we'll look at is what is called the VI characteristics of a diode. Remember what VI characteristics are? VI characteristics is the voltage current curve, and you know the voltage current curve for a resistor, for example, which is a straight line, right? So similarly, let's get the diode VI characteristics in this video. And my guess is you already know what it would look like, right? Because you know the behavior of the diode for different voltages that we are applying to the diode. So here's what we are going to do. So on the y-axis, let's put the current, and on the x-axis, let's put the voltage. Okay, let's put voltage here, and on the y-axis let's put the current through the diode, and let's define the voltage and the current in a specific manner as we did in the previous videos. So if this is the diode, we are defining the voltage in the forward direction uh, as the positive voltage, and the current in the forward direction as the current that we need. Okay, so what would the diode characteristic look like? So what happens to the current when V is less than 0? So when you are in this uh, place, what happens to the current? The current is 0, right? There is no current that can flow through the diode in the reverse direction. And so when the voltage here is reverse, we are in the reverse bias region, and this current is going to be 0. What happens to the current when the voltage is positive? When the voltage is positive, you replace the diode with a short. Okay, so as much current as needed can flow through the diode, and therefore the characteristic would basically look like this, right? At any voltage just above 0, you'll have it can supply any current that you want. Okay, so this is the VI characteristic of a diode, and of course this area is called the forward bias region, because that's where you have a positive voltage and you will have almost an infinite current. Of course, the current is going to be limited by what we connect to the diode, right? If we connect a resistor here, the current is going to be limited by the resistor, and so on and so forth. So on the other side, you have zero current, and this is called the reverse bias region of the diode.